This is Math 90, Section 5.4 on adding and subtracting polynomials. This section is going to be very similar to the section we did back in Chapter 2 with combining like terms. So remember that like terms have the same variable part. Okay? Their coefficients may be different, but they definitely have the same variable part, meaning that they have the same exponent as well. Now, remember that to combine like terms, you add or subtract, whichever the case may be, the coefficients, and you keep the variable part. Okay, so you don't change that variable part, you're keeping that. Okay, so let's look at an example. Now, a good thing to do is to maybe watch the first example, and then after that, pause the video, try to work ahead of me, see if you can do these. You don't just want to try to learn by just watching me do it. It's much easier to watch me and follow along than it is to just have the problem and blank space in front of you. You want to be able to work this without any kind of assistance. Okay, so if we're just combining like terms, you'll see that I've underlined these similar terms, these like terms. I've got the x squares and the constants. Those are the two pairs of like terms. Normally, I would not write those ones in there, okay, because those are unnecessary. But I put them in there just to show you how they combine. So this x squared plus this x squared is 1 plus 1, which is 2 x squared. Don't make that an x to the fourth. You're not multiplying. If you were multiplying x squared times x squared, then you would add the exponents. But that's multiplication. We're not. We're adding. This 2x didn't have a like term, so he's just along for the ride. Minus 3 plus positive 5 is positive 2. And I just made little notes down here to tell you where these numbers came from, just in case you're looking at it and wondering. That's about as good as we can do. None of these are like terms, so we can't combine any of these. Now, you could factor out a 2 if you knew how to do that, but I don't expect you guys to know how to do that because we're going to do that in the next chapter. So that's as good as we get. Now, remember that combining like terms does not use our exponent rules. We're just combining the coefficients. The exponents are used to identify the like terms, and then we combine the coefficients. Okay, so let's go to the next page, and I'm going to cover up these answers for us. Now, this is a good opportunity to pause the video, try to work ahead of me by combining those like terms. Okay, so you can see we have x squared like terms, we have x like terms, and we have constant like terms. So we have three sets of like terms here. So we have 1 plus 5, which is 6 x squared. Let me slide this down a little bit. There you go. 6x squared. Negative 9 plus negative 2 is negative 11x. Positive 2 plus positive 9 is positive 11. Again, these are not like terms, so we can't combine anything, so we're done. It's good to practice these so that you know when to stop, because otherwise you guys get the correct answer and then you blow past it trying to do more, assuming that it's like an equation where you have to get something nice like x equals 2. Okay, here's another addition. This is a good opportunity to pause the video and try to work ahead of me a little bit and see if you can do this one. The only set of like terms are the constants. Everything else is just along for the ride. So, writing down all these extra things and just combining the constants. Negative 5 plus positive 1 is a negative 4. Now you'll notice that the order in which I wrote these, I always write these in descending order, meaning that my highest power is first, and then my powers descend from there, and my constants last. That's not necessary. That's pretty standard, but it's not necessary, even in Hawks. So if you write these out of order, that's okay. So if you wrote negative 4 first, and then you wrote plus 9x to the 8, and you jumbled up the order of these, that's fine. It's not going to matter. Okay, so let's do some subtraction. Subtraction's got a little quirk to it. So it's very similar to the addition, but with subtraction, you got to remember that we're subtracting every term in that parentheses. So we need to subtract every one of these. The easiest way to remember to do that is to distribute this negative. You're also distributing this -1 times all three of those terms. So what I've done, you'll notice that I did that in red. And next up, I color-coded all the signs that changed as a result of that distributive process. So I've got these three, which are not affected by the negative. And then this negative times that +3 became a negative. That negative times that negative is a positive. Negative times negative is a positive. Then it's just a matter of like terms. But you got to remember that you have to distribute this negative first before you can combine like terms. So don't try to combine 5 plus 3 and get 8. Then distribute, because this is multiplication. That's -1 times this. The order of operation dictates that we do the multiplication before the addition or subtraction. Okay, so now we've got like terms. We got to buddy up here. We got the x to the 4th like terms and the x to the 3rd like terms. So that's going to be my final answer. 5 minus 3 is 2, x to the 4th. Remember, you keep that variable part. Don't try to make that x to the 8th. You're not multiplying those variables. Then the x to the 3rd is 8 plus 1 is 9. 6x and 5 are just drop down. Along for the ride. Okay, so next up, B, we have same situation. This is a really good opportunity to pause the video and distribute that negative and try to combine those like terms. Okay, so we have this negative that's going to have to be distributed. Again, I used the red to accent which signs are going to be changing. So you can see that negative times that negative becomes a positive. That negative times that positive becomes a negative. And then my like terms are just these x squared terms. So that -3 plus 2 becomes a -1 x squared. So we have the 7x cubed, the -1 x squared, and the -10. This is a perfectly good answer, but we both know that if you put this in Hawks, it's not going to like this answer. Okay? It doesn't like unnecessary ones. So if you put this 1 in there, it's going to tell you that your answer is not simplified. So don't put that 1 in there. You're going to want to put 7x cubed minus x squared minus 10. So don't put that 1 in Hawks. It doesn't like it. Okay, so let's do some that are a little bit bigger and scarier, and that'll finish up this section. So let's do 2 more that are pretty messy. All right, so that looks pretty menacing. We're going to need to simplify that stuff in the brackets and then subtract. So don't try to go ahead and distribute that negative just yet. There's other stuff that can be done inside this bracket. Again, I'm following the order of operations. So I'm going to distribute that 3. And as you can see, I did some color coding here. So that became 3x minus 6. So everything in blue came as a result of distributing that 3. These just drop down. Now I'm going to go ahead and combine these like terms that are inside here. 3x plus 7x. Don't worry about that negative yet. Let's just forget about it for now. 3x plus 7x is 10x. Minus 6 minus 1 is minus 7. So I'm just simplifying the brackets by themselves. Now that those are simplified, now I've got that negative, that subtraction, that's going to be distributed. If you wanted to distribute this negative beforehand, you could have. That would have eliminated the brackets. But I chose to clean this up before the subtraction. So now, again, with my use of color here, that minus times this positive became minus 10x. That negative times that negative became positive 7. So these red indicate the changes that came as a result of that distributing process. I have 2 like terms to combine, and that's a positive 4 minus 10, which gives me a negative 6x. And then the plus 7 comes down. I realize there's a lot of stuff happening in there. There's a lot of order of operations and stuff that has to happen. So, okay, so let's do one more that's kind of messy like this. This is a good opportunity to pause the video, write this down, and try to work ahead of me. As you can see, I've got that -4 circled there because I'm going to distribute it into that parenthesis. I'm going to take the same approach as last time and simplify the brackets. So I got that 2x minus, still have my brackets. That's going to be a -12x minus 8. The blue stuff is what changed as a result of distributing that -4. Make sure you're distributing the minus and the 4. I'm going to combine the like terms inside here. So just forget about the 2x for now. Those are like terms, those x's, and those constants are like terms. So if I combine those, I get 2x minus, that comes down. My brackets simplify to be 9 minus 12 is -3x. -8 plus 7 is -1. Just like last time, I'm going to distribute that minus. At any point along these steps, you can always pause the video and try to figure out, what I'm doing, or correct your mistake, and then try to, continue working ahead. So distributing that minus, it's going to change those signs, so you can see how I did that in red. Then I have these two, so that negative times negative is a positive, negative times negative is a positive. And then these two are like terms. I can combine those into just 5x, and the plus 1 comes down. These are not like terms, so they can't combine together, so you can't make that 6x. Okay, so that completes this section.